Alright, this is the independent practice from lesson 6.3, and we're on the final couple questions, numbers 14 and 15. We're going to start on number 14 here. Once again, this video will help you set the problems up. It will not solve the problems for you. Number 14 reads, one patterned blue fabric sells for $15 every 2 yards, and another sells for $37.50 every 5 yards. Do these fabrics have the same unit cost, and explain? So if you forgot what a unit cost is, it's probably a good idea to remind you what a unit cost was. So I'm going to use a different example to help you on this one. Let's pretend that you could buy 4 pizzas for $32. Now that's a rate, but it's not a unit rate, or it's not a unit cost. A unit cost is when you would try to figure out the price for one pizza. So that's what a unit cost is. So maybe I'll even write that right here. A unit cost is when you don't care about the cost for 4 pizzas, you care about the cost for 1 pizza. So you would divide this by 4, and you would get $8 for 1 pizza. This is a unit cost. A unit cost is when you get the price for 1 pizza. So now, we're going to do the same thing on these, except we're talking about this fabric. So there's 2 different deals. One of them is $15 for 2 yards. And the other one is $37.50 for 5 yards. And this is not one where I try to figure out if they're equal to each other. Well, you are actually trying to figure out if they're equal to each other, but I wouldn't set it up next to each other. What I would do is simply find the unit cost of this one, find the cost for 1 yard, and find the cost of this one, find the cost for 1 yard. Now you're going to do that in different ways, because on the one on the left, you're going to divide by 2 to get from 2 yards to 1 yard. So divide $15 by 2. The one on the right, you're not going to divide by 2, because if you divide by 2, you won't get from 5 yards to 1 yard. So you're going to divide by 5 instead. So I would try 2 division problems with money. It's going to require a little bit of thinking about where the decimal goes. And basically, if you get the same answer here, if this answer and this answer are the same, then the answer is yes, they have the same unit cost. If they are different answers, then no, they don't have the same unit cost. That's what you should try for number 14. Go ahead and give that a try. Pause the video, resume it when you're ready to check out number 15. Alright, so number 15 says to complete each ratio table. And they're different from each other. Personally, the numbers look a little easier on the first one, but the operation seems a little bit easier to me on the second one. So I think what I'm going to do is try and give you a hint on the second one first, and then I'll give you a hint on the first one second, because it doesn't really matter which one you do first. So the numbers don't look so friendly on the second one, but I do want you to notice the first term right here, 80.8, and then the second term, 40.4. Boy, that seems like maybe they just divided that by 2. And so you could check that. I don't even mind using a calculator to just check that. 80.8 divided by 2 is 40.4. So that's a really interesting idea. Perhaps along the top here, they're just dividing by 2. So maybe that's what's happening here. You divided this one by 2, and then what are you going to do there? Well, it's worth trying. You could try dividing that by 2 and see what you get. I just want to remind you that if that's what you decide is going on, let's say you're dividing by 2, divide 2, divide 2, divide 2. If that's what's happening, then you got to do the same thing along the bottom. You got to divide this by 2 to get 512, divide 512 by 2 to get 256. Actually, that's worth checking too. Why don't you just punch that in? 512 divided by 2. I'll just let you finish that. That's an interesting idea. So use your calculator to experiment a little bit with that and try to find those 3 missing numbers. I think I gave you a nice hint there. I'm going to go ahead and go over to this first one now. This one requires, I just worked this one out a minute ago, and this one's going to require a little bit more work. The numbers are pretty easy, but explaining how to get there is not super easy. So some kids would look at the top here and they would notice that to work our way from the to work our way backwards like this. Some kids would just kind of guess and check that that number might be a 6 here, because they're going to get from 24 down to 18, subtract 6, and then down to 12 and subtract 6. So you could plug a 6 in right there, and it's not the worst idea. In fact, if you did that, you just kind of got to check to see if that's right. And one way to check that would be take these two terms and ask yourself if they're equal to these two terms. Well, how would you do that? Well, I'd actually use a calculator. Well, you don't need a calculator for the first one. How would you get from 6 to 24? You would multiply by blank. Well, if you would do the same thing to this term right here to get 18, then you know you're on the right track. And then you would use some other common sense to notice things like if this term is 6 and this term is 12, that's just doubled. So then if this is 4.5, all you have to do is double it to get this term. So I just gave you some nice verbal hints. I know the visual hint there is not the best hint ever, but I gave you some nice visual hints there on what to try to get those missing numbers. Probably the best thing you could do is use your calculator to experiment, and then of course check your answers with your peers.